Hi guys, this is a chemistry film festival and we're going to go through the chemistry in Dr. Stone.
Let's move it somewhere else.
What does a sorcery battle even look like? They aren't gonna start shooting fireballs and burn us alive, are they? Please stop! At least don't do anything dangerous! I don't want to die!
All right, ready for some badass sorcery? Check out my rainbow bridge! I am the master of the flames and fire!
He did it! He made the fire turn yellow! It changed again! It's greenish blue! And now it's purple! Wow! It's crazy!
Sorcery.
Rainbow Bridge? What total crap. They're reactions to basic flame tests. You threw salt, copper, and some sulfur into the fire in that order. So the copper, is it copper sulfate? He wouldn't know that. Did you use some blue crystals? Maybe you found them in the caves?
Oh, shit! How in the hell would a total outsider like him know about the blue crystals? He must be able to read my mind or something.
In the clip, we see Chrome and Seppuku, I'm just going to call him Dr. Stone for the rest of the presentation, have a sorcery battle. In the battle, Chrome uses different materials to change the color of the fire. The sorcery above is actually what we call a flame test. So what is a flame test? A flame test is a procedure used in chemistry to detect the presence of certain elements such as metal ions. This is found by using each element's emission spectrum. But visually, all it matters is when a compound such as metal ions is thrown into a flame, like in the clip, we see that a flame seems to change color. So it goes from like red to yellow or red to green or red to purple. So how does a flame test chemically work? When a metal atom absorbs heat, the electron of the atom goes from its ground state to its excited state. So in the picture, you see that an electron will go up one energy level or multiple energy levels after heat or such as fire is added. The excited state of the ion is very unstable, so it will try to release the energy absorbed. So energy is quantized in the atom. They can only absorb certain amount of energies and release certain amounts too. Like the bottom picture shown, they can only go from like level 6 to level like 5 or level 5 to level 2 and things like that. Since we know that energy is equal to Planck constant times frequency, and we know that each atom has a different emission spectrum, so they have different energy levels and wavelengths they can release, only certain frequencies and colors of light can be emitted. So we want to know, is Dr. Stone right? Dr. Stone said that Chrome threw in salt, copper, and sulfur in that order. So let's do a quick flame test check. The first flame in the clip was yellow. This is consistent with Dr. Stone's suggestion that it was the salt. Since the yellow flame is usually either sodium or iron, we can't, and since the flame test is a qualitative test, we can't tell the difference between the two. But then since they're on an island, it is more likely that it is sodium because sodium is more common. So this is why he suggested that the first flame was caused by a salt. The second flame is green, and we can either think it's either barium, copper, or boron. But since Dr. Stone saw that a chemical thrown in the fire looked blue, and he was able to confirm it with Chrome that the thing that he threw in was from a blue crystal, this is suggested as copper because copper is blue in its solid state. And the third flame was purple-ish. Dr. Stone suggested it to be sulfur. The sulfur usually has a flame that is usually blue, but then it might have like purple due to the presence of both red and blue flame. So that's why it might have like purple. I'm just gonna end this off here with a cool clip of a volcano I found.
In a geographically rare phenomenon, this volcano in Indonesia is burning blue, but it isn't the result of strange coloured lava. The blue flames are caused by the combustion of sulfuric gases, which emerge from vents at high pressure and high temperature. Some of the gases condense into liquid sulfur, which continues to burn as it flows, creating the illusion of blue lava. Despite the noxious gases, local workers scratch out a living here, gathering the sulfur which is used in the chemical industry. Cameraman Mark Cheglat had to wear a gas mask while filming, but many of the workers here do not, which can have adverse effects on their health. Ceramic pipes have been installed on the active vents to route the sulfur gases down the slope so they cool and condense. The liquid sulfur then drips and solidifies, after which it can be broken up and collected. Then the sulfur is carried up the steep wall of the crater, followed by a 3-kilometer walk to the loading station. Despite the dangers, the naturally occurring blue flames and the turquoise acidic lake in the volcano's crater have become tourist attractions.